am Mrs. Rajakumari, Assistant Professor of Mathematics in RMD Engineering College. In this lecture, we discuss probability, an essential tool for today's engineer. Theory of probability is used in every branch of engineering. It is a powerful tool that helps engineers model and design the technology they develop. They apply probability to explain and analyze the time-dependent or chance-dependent performance of systems. This series of videos attempts to equip engineers with necessary working knowledge in probability. This lecture series will include these 14 topics. The main objective of this lecture is to introduce 5 basic terms which serve as a starting point in the study of probability theory. A good engineer knows the importance and advantage of using a mathematical model which correctly predicts the behavior of an actual experiment without rather performing the experiment itself. Probability is used in every branch of engineering. For example, probability is fundamental in queuing theory and the design of modern communication systems. It is applied to predict computer network traffic and analysis of design of networks. In information theory, which is key to data compression and the design of error correcting codes, relies heavily on probability. Modern methods for information retrieval from the web, mathematical models of the web, and other complex real-world networks are built on probability theory. Control systems in the real world are subject to random disturbances and noise. Electrical and electronics engineers use probability to model and design such control systems. In signal processing, probability is used to decide whether the received waveform by a radar detection system is noise only or a signal plus noise. And in the design of computer memory to hold k-bit words, what is the probability that at least m bits are correctly read back? This can be well modeled by binomial random variable. While determining the performance of optical communication systems, the number of photoelectrons produced by its photodetector is well modeled by the Poisson random variable or a Poisson process. Gaussian density function plays a prominent role in the analysis and design of wireless communication systems. These are only a few of the applications of probability in engineering. It is also widely used in mechanical engineering, civil engineering, chemical engineering, etc. Well, let's now get into the topic on the basics of probability. What does the term probability generally mean? It is a numerical value measuring the occurrence or the non-occurrence of a random event. Before defining probability mathematically, let us use our reasoning to understand the probability line which is shown in this diagram. It shows that the value of probability of any random event always lie between 0 and 1. Depending upon the chances of happening, an event may be described as impossible, very unlikely, unlikely, equally likely, likely, very likely, or a certain event. In this likelihood scale, an impossible event is assigned 0. Equally likely events are assigned 1 by 2 and a sure event is assigned 1. Now let us start learning the basics of probability theory using mathematical perspective. If we want to give a good start while learning the subject of probability, it is important that we know very clearly about these basic terms such as random experiment, outcome, sample space, event, trial. What is a random experiment? Suppose we flip a coin or roll a die or try to know when a mechanical component will fail. In such experiments, we cannot predict the result before the experiment is done. These are called random experiments. An experiment whose outcomes cannot be predicted is called a random experiment. To perform a random experiment once is called a trial. How many times it is repeated is called the number of trials, denoted by n. What is outcome of a random experiment? It is precisely one of the possible end results of an experiment as outcome. When a coin is flipped, head one outcome, tail another possible outcome. What is a sample space? It is a mathematical abstraction used to represent all possible outcomes of a random experiment, denoted by S, sometimes by omega. When a coin is flipped, the sample space S is the set containing head and tail. When a computer memory reads an n-bit word, the sample space S is the set containing n tuples b1, b2, etc. bn, where each bi is either 0 or 1. In the case of number of photoelectrons produced by a photodetector in an optical communication system, the logical sample space is omega is equal to the set containing 0, 1, 2, etc., which is an infinite sample space. Here are few more examples of sample spaces. When an integrated circuit is tested to determine whether it meets quality objective, the possible outcomes are accepted and rejected, denoted by A and R respectively. The sample space S is the set containing A and R. Suppose a manager supervises the operation of 3 power plants. At any given time, let each of the 3 plants be classified as either generating electricity or being idle, represented by 1 and 0 respectively. Then the sample space S in this case is the set containing these 8 elements. The most significant term in the study of probability is event. If a student wants to study and solve probability problems confidently, he or she needs to identify and define the event involved in the problem whose probability is to be calculated. Because by probability we always mean probability of a random event. Whenever we use the term probability, we mean to talk about either probability of a random event or the probability of a random variable characterizing that random event. Students sometimes take the two terms outcome and event for granted and use them interchangeably and end up in wrong answers while solving problems. Throwing a die, the sample space S is the set containing 1, 2, 3, etc. up to 6. 2 is an outcome. Getting 2 denoted by singleton 2 is called an event. So an event is an outcome with a description or attribute. Therefore, elements of event set are also some of the outcomes of the random experiment. Remember, outcome is an element of sample space. Event is a subset of a sample space. Event E occurs if the actual outcome of the experiment is in the set E. Event of getting even numbers, that is the set containing 2, 4, 6 occurs when one of the 3 outcomes 2, 4, 6 appears. When a coin is tossed. Tossing a coin is a random experiment. Head and tail are the possible outcomes. The set containing head and tail is the sample space. Singleton H, that is getting head, singleton T, that is getting tail, are possible events. When a die is thrown. Throwing a die is a random experiment. 1, 2, 3 up to 6 are the possible outcomes. The set containing all the possible outcomes is the sample space S. Getting 1, getting 2, getting 3, etc. that is singleton 1, singleton 2, singleton 3, etc. are some simple events. Getting an even number, that is the set containing 2, 4, 6. Getting an odd number, that is 1, 3, 5 are some compound events. In a simple event, only one outcome favors the happening of the event, whereas in a compound event, more than one outcome favors its occurrence. So far, we have been talking much about the term event. Now, let's take a look at this diagram. This shows an overview of the development of subject content in the study of probability. In the first stage, probability of random events are discussed. In the second stage, the concept of random variable comes to represent the random events. There we discuss the probability of corresponding random variables instead of probability of random events. In stage 3, Random variables are characterized by probability functions which carry all the probability information related to the random variable. Next, these probability functions of random variables are characterized and represented by moments of random variable. Moments are defined to carry all the significant probability related information to a random variable, which are generated by moment generating functions. Random variables are categorized into discrete and continuous, which are characterized by their respective probability functions, namely probability mass function and probability density function. Mean and variance are two important moments which carry all the significant probability information related to the random variable. These are the major topics which will be covered in probability. If we take the concept of random processes, it is an ensemble of random variables at a fixed time t. Hope you understood the basic terms used in a study of probability. In the next lecture, we will learn the various mathematical definitions of probability, the axioms of probability, types of events, and simple problems. Thank you.